Hello students, today we are going to solve the ninth numerical of biochemical oxygen demand. Question will be given as what will be the BOD of the mixture at a distance of 10 km from the mixing point in the direction of the river if the area of river is 80 meter square, value of K is 0.21 per day, and BOD5 of the mixture at mixing point will be 44.7 milligram per liter if the discharge is 8.5 meter cube per second. It means that suppose that there will be a river flowing in this direction. Okay, now at this point we had added the sewage water. Now when we add the sewage water at this point, that point is known as mixed point. Okay, now we need to calculate the BOD after traveling a distance of 10 km from the mixing point. It means that if the water travels a distance of 10 km from the mixing point, then what will be the BOD at this point after 10 km from the mixing point? Okay, now the discharge is given as, total discharge is given as 8.5 meter cube per second. Okay, and BOD of the mixture at this point, that is at mixing point, will be given as BOD of the mixture at mixing point will be given as 44.7 milligram per liter. Okay, it will be equals to 44.70 milligram per liter. Clear? Now if BOD of the mixture is given, that is the 5 days BOD of the mixture, so can we calculate the ultimate BOD from this point? Definitely, it will be equals to Y5 will be equals to L naught 1 minus e to the power minus kt. Okay, value of k is also given in the question, which will be equals to 0.21 per day. That will be the value of k, that is 0.21 per day. So we just write here as 5 days BOD will be equals to 44.70. We need to calculate the value of L naught. 1 minus e to the power k value is 0.21 and t will be equals to 5 day. From this we can determine the value of L naught, which will be equals to 68.76 milligram per liter. That will be the initial or the ultimate BOD. Okay. Now we had computed the ultimate BOD of the mixture. Now we need to determine the time to travel a distance of 10 km. Okay, surface area or the cross sectional area of the river is given as 80 meter square. So for calculating the time we need what? Distance upon velocity. Now we had distance, that is 10 km, but we want to calculate the velocity also. Now for the velocity calculation, what we need to generally do? For velocity calculation, we need to divide the discharge by the cross sectional area. Now discharge is given as 8.5 meter cube per second. Okay, now we need to convert this in meter cube per day, for which we need to multiply here 24 into 3600 divided by area, which is given as 80 meter square. Now when we solve this equation, we will have the value of v, which will be equals to 9180 meter per day. Now we will convert this velocity into kilometer per day, which will be equals to 9.180 kilometer per day. Now we had computed the value of v. Now we will use this value of v here and we will compute the time. Okay, now time will be equals to distance upon velocity. Now distance will be given as 10 kilometer and time velocity will be equals to 9.180 kilometer per day. Now after solving this, we will have the time, which will be equals to 1.08 day. Now time to travel a distance of 10 kilometer from the mixing point, okay, will be equals to 1.08 days. It will be equals to 1.08 days. Now the time from the starting of the mixing point, that is from the ultimate point, will be equals to what? From the ultimate point to this mixing point, 5 days is already left. Okay, or 5 days had passed already. Now for traveling a distance of 10 kilometer, 1.08 days also required. So what will be the total time? Total time required will be 5 plus 1.08 from the ultimate point or from the starting point. Ultimate or starting point. Okay, now we know the value of time, which will be equals to 6.08 days. So the total time taken from the starting of the process will be equals to 6.08 days to reach a distance of 10 km from the mixing point. Now we need to calculate the BOD after 10 kilometer, that is BOD at 6.08 days, which will be equals to L naught 1 minus e to the power minus k into 6.08, because the value of t here is 6.08. So we had calculated the value of L naught, which will be equals to 68.76 milligram per liter. Okay, now 1 minus e to the power minus k value is given in the question, which will be equals to 0.21 into 6.08. Now after solving this whole equation, that is 68.76 into 1 minus e to the power minus 0.21 into 6.08, we will have the final BOD of this sample after 10 kilometer of distance. It will be equals to 49.58 milligram per liter. That will be the BOD after 10 kilometer of distance from the mixing point. That is the final BOD of this sample, which will be equals to 49.58 milligram per liter. Okay, students, we had solved this numerical completely. Thank you very much.